Good morning, everyone. Thank you for attending. Um, so just so everyone knows, the QA we've disabled for this time. So please just put any questions that you have in the chat. But my name is Ted Cross. I'm VP of Product at Novi Labs. This morning, our subject is our automated PDP forecast data product, which is a really exciting release that we have out there. So let me go ahead and share my screen. And give me a message in the chat if you're having any issues there, but looks like it's going okay right now. So let's go ahead and get into it. Okay, so what are we going to be discussing today? Well, we're discussing our PDP forecast solution, and the way that we're going to break this out is into a few different pieces. We'll start by describing the problem. Why do we need machine learning for automatic forecasting? Then we'll describe our solution, our algorithm that provides live, accurate PDP forecasts across the lower 48. We'll give you details on accessing and using our PDP forecasts, and then leave plenty of time for Q&A at the end, so that any questions that you have, we can answer for you. So we wanted to just start really quickly here with our goal. Why did we work on these PDP forecast product? And really, we want to have investment grade forecasts for every well in lower 48. We have customers spanning the E&P value chain, from investors to operators, service companies, and producing well forecasts are kind of at the core of a lot of workflows, and we want those to be at the level that you can actually underwrite investments off of. So why does PDP matter? And for those of you who don't know, maybe you're from a different part of the industry, but PDP stands for Proved Developed Producing, which is an SEC reserves terminology. But really, the key thing here is it's shorthand for a well which is already producing. So kind of like a post-drill forecast. And these forecasts are important for a variety of different workflows. They're important for asset valuation. Usually, a lot of the value of the forecast is caught up in the producing volumes. You don't require usually any additional capital investment. That's just money coming in from the bank. These are key for regional forecasting. So if you're trying to understand how much production is going to come out of the Permian Basin, or from the Williston Basin, or from Karnes County, wherever it is, PDPs are an incredibly important part of that. These are key for operator benchmarking. So what's the producing wedge going to look like for different operators? Maybe you're considering different investments. Type curve workflows use PDPs as their inputs for the average that's being used. And midstream planning, underwriting whether or not you're going to build a offtake facility, pipeline, gas plant, whatever it is, you have to have an estimate for how much is going to be produced in the future. And that's just probably a small sample. You guys here can probably come up with another couple dozen ideas there, but those are kind of five important ones. And one thing that's important to note for these, and I'm just kind of showing you a little plot over here on the right. So this is daily oil production from the U.S. lower 48 from all the different horizontal wells, which is over 9 million barrels a day right now. And you can see here we're coloring each of the production wedges by the year when the well came online. And actually 50% of the production is coming from wells that are 18 months or younger, AKA the young wells. So that's just kind of like an artifact of the fast decline of these PDPs that we have here in the United States with these unconventional wells. But if you're drilling a conventional well, it'll decline less fast, but that doesn't mean that it's not important. So how do operators or engineers or other typical oil and gas workers use right now to forecast PDPs? Things like type curves, decline curves, which can be informed by different methods, and we'll get into that a little bit more. But those existing methods, they can be unreliable, they can be inaccurate, they can be biased, and they can struggle with young wells. What we've heard a lot from different customers and prospects that the forecast looked great initially, but it missed the change and decline in the future. Or, wow, those EURs do sure seem to be optimistic. You guys have probably heard variations on that in your own work with PDPs, or as you've looked at producing well forecasts from other automatic forecasting solutions. So I wanted to throw in here just a little thought exercise that you guys can have as you're sitting there in the audience, which is, how would you forecast these wells? So um, I have two sample wells here, and for both of these, I have a pretty standard plot where we have the log of the oil rate on the y-axis and then months on production on the x-axis. So let's say we have one well that started producing, we have 1 month of production, and it produced 500 barrels a day for that month. Then we have another well that's been producing for 9 months, but that production has been mostly flat, hanging out right around, 180 to 200 barrels a day there. With a traditional decline curve analysis, where you're trying to fit a hyperbolic curve to the prior production, you're to be honest going to have a little bit of a struggle with these wells, as there's not much to fit a decline curve to. You have one where you only have a little bit of production, and then you have another where you have 9 months of production, but there's not really a decline curve that's yet been established. So to think about ways that we might approach this problem, I've just kind of laid out different data types and different methods here, where you have post-drill data, and this is things like the peak rate, the yearly decline, the change in the decline rate, pressure, well operations, and then you also have pre-drill data, things like geology, completions design, interwell spacing, parent-child relationships. Traditional methods for a decline curve analysis really focuses on the post-drill data. There's not a whole lot of attention paid, if any, to pre-drill data. And this is all useful stuff. The geology should impact the well's decline behavior. Completions design should impact the well's decline behavior. Interwell spacing, parent-child, all of that affects how wells decline. But that information is not used in a traditional decline curve analysis. Now, some folks, maybe you inform your B factor or different decline parameters by looking around at nearby wells, but that's nowhere near as sophisticated as the analysis that would go into a type curve or another pre-drill forecast. So to situate where our algorithm sits in the space over here, the blue, I would say this Venn diagram, the blue circle shows you different methods that learn from geology, completion, spacing, and parent-child. And then the orange circle over here is the use of prior production history. And a traditional standard type curve that uses geology, completions as you're kind of maybe filtering to a certain area, choosing the wells you're going to be using for your type curve, maybe an adjustment for things like a lateral length or something like that. And Novi's pre-drill forecasting method, which uses machine learning, uses all those variables as well. On the other hand, you have the use of prior production history. So you have a well which is already producing, and that's new data that's coming up. And that would be what is used in traditional DCA. But the real opportunity here is, well, what if you can leverage all of that data from before the well starts producing? That's all useful information, along with the production history of the well, is also extremely useful. So in the ideal world, you would use both of those. And I'll demonstrate here that you can have a big increase in your accuracy by combining them together. So before I get into the details about that, just a little bit of timeline or history for our development for our PDP algorithm, which really we have spent many years working on at this point. The company goes back through 2015, Novi Labs, when we were founded, with our initial focus really being on pre-drill forecasting, in which we have multiple patents on. We've done data modeling, forecasting, built a lot of infrastructure for all of that. Things like calculating spacing, calculating parent-child, building tools to quickly extract out subsurface properties at the well location. And all of that's been refined through our work with top operators. Then we have the PDP algorithm development. So that is things like leveraging what we have built here on the pre-drill side to apply it in this new case. We have a patent on that one, which we applied for in 2021. We wrote an SPE ERTEC paper about it with Pioneer. You can go read that. And that's been used in our forecast engine tool by our machine learning platform customers now for 4 years now. So it has a lot of battle testing, if you would, in the wild. But over the past 18 months or so, we have been working on implementing that same algorithm that we had developed for operators to forecast their own wells. Now we've repurposed it to automatically forecast wells as a data product. So, we go out and collect data from all the different data state providers and things like that and other proprietary sources. And wouldn't it be great if you had super high quality investment grade unbiased forecast ready for you live that just updated as new data came in. And this is something that we actually started releasing it last fall. We started with the Permian just because it's such a big part of the production wedge. And it's had evaluation now in that kind of limited release from operators, financial services, and more. Now we cover the whole lower 48, but it's been evaluated pretty thoroughly already. So just how accurate can it be? So here what I'm showing you are forecasts for young wells from the Permian, the Williston, and Appalachia. And on the y-axis for each of these, I am putting the error for an automatic decline curve method and a Novi's machine learning method. And the auto DCA method here, this is actually something that we have worked on for years, evaluating many different techniques and finding the one that gives the best accuracy. So this is, trust me, we are not sandbagging. And this is, in fact, the method that we use live today in our product as a fallback if for whatever reason our machine learning method fails to make a solution. So that is the same algorithm that we use a lot in our current product. We use it for vertical wells. So trust me, that's a real algorithm there. But what this shows you is how the error score from the auto method or our machine learning method for these young wells as you get further into the forecast. So this would be for month 1, month 2, month 3, all the way out to month 13 for these 3 basins. And this is on our 1-year back test. So what we'll do is we'll withhold data from a year, train the model, make a forecast, and see how it performs on that data. And what you see is a dramatic improvement across the board. This would be on the oil production from the Permian and the Williston, and on gas production from Appalachia here. They probably do very similar. You see here, they're nearly identical at predicting what the next month will do. But as you get longer and longer term, that's when the additional data that the machine learning based algorithm has access to is really helpful in generating a more accurate forecast. All right, well, now let's get into a little bit more details about how it works. The first thing, I've said this several times here, but it is machine learning based. That means that it's not just curve fitting. So, a lot of these methods will try to fit an ARPS equation or some other parametric curve to prior production using, there's a variety of different methods for how to do that. But ours is machine learning. So it's attempting to predict the decline without any parametric curve that's baked into it. I'll get into that a little bit here in some more detail, but it does include a couple different methods. There's tree-based methods and other algorithms that are ensembled together in our forecast. There is a time variant features can be included as the input. So if the well spacing or parent-child is changing, that is included. We do use the prior production, and a lot of the algorithms power actually we had to figure out different ways to parameterize, featureize the prior production, and it minimizes human bias. Second, it's an autoregressive. So this is a common technique which is used in domains like ours that have forecasting where you're getting pieces of data back and updating your forecasts iteratively. This is really powerful, but it can be unstable, which we had to put a lot of time in to make sure that it was unstable and when it spin up or spin down in an autoregressive fashion. But that gives it the ability basically to update as you get more data back. So in this example, the black would be the prior production, or the black would be the actual production of the well. The yellow there would be our pre-drill forecast. And then the other colors here, orange, red, blue would be the forecast as you get more data from the well producing. So you can kind of think of it as the model kind of has like a baseline forecast that it makes, and then that will update as more production data is received. And then on the other side here, and I'm just going to keep hammering this home, it does use more than just production data. So geology, completion, spacing, etc. This gives it better accuracy and reliability versus curve fitting. This is especially useful where you have noisy data, where you have other kind of situations that can cause a curve fit to be difficult. And the way that we like to think of it is kind of this unification of pre-drill and post-drill models. So a little bit in the process here for how this works under the hood. So we get production data and other pieces of data flow into our database for processing and model training. So, we get production data from the state sources. We also get production data from operators or minerals companies who provide it into our data network. And then we have geology, header, completion, spacing, parent-child, all those other data types that we process and extract and put at the well locations goes into our database. So then we have a step where we train machine learning models and we QA/QC them. These are done with an automated backtesting approach that we use to evaluate the accuracy of the models. We have automated forecast quality checks. We have a reservoir engineer do a qualitative evaluation to make sure that they're matching that special reservoir engineering touch and years of experience. It gives you a way to kind of quickly evaluate the quality of a forecast. And then those models are published, and then from time to time we refresh them with data. So after the machine learning model is built, then we go to generate the forecasts, and this is an ongoing live process. So as any new production data comes in, we'll reforecast a well. If we have new neighbors, we'll reforecast a well. If the forecast fails our quality checks, we will revert to a curve fit. If the curve fit fails, we'll revert to our previous forecast, and if for whatever reason we can't make any valid forecast, and we'll just give you nulls back for that. So this is basically designed to give you the best forecast possible, as reliable as possible. Of course, it's not going to be perfect, but it's going to be dramatically better than traditional methods here. And then all that data is then published into our Insight Engine product. So that's the name of our data service. It's available in both dashboards, so ways for you to go through and view those for different use cases, and it's available through our API. So you can integrate it into your own systems through that API. Okay, the outputs. So geographic scope, this is funny, a little typo there. That's what I get for doing some last minute edits. But geographic scope is lower 48 wide. So I think we cover over 99% of wells with the forecast. It includes vertical wells and horizontals. Production streams, oil, gas, and water, or condensate, gas, and water, depending on the field. Well age, as long as we have 30 days of production, we'll forecast it. We will forecast for 50 years from initial production. We do provide 30-year EURs in our table, as well as the 50-year EURs, but we wanted to go as far as possible in order to capture some folks who prefer like a longer term view, and that's from initial production, not from the forecast date. As I mentioned, both verticals and horizontals are covered. Just a little caveat there. The verticals, we don't use machine learning. We just use a curve fit for those. They're such a small piece of the production today, and generally they tend to be older in life, at which point the curve fit is just as good as a machine learning forecast. So that's just a little color there on that. And then we deliver them as volumes and as segments. So basically, we'll have some tables that have the volumes in them, and then we'll have other tables that have the segments. The segments, these would be a linear ramp-up segment, if applicable, a hyperbolic segment, a second hyperbolic segment, and terminal decline. So you can kind of see the view over there on the right showing you how that works. and those all tie together. So those segments and the volumes are exactly the same. Okay, so where can you go and access these PDP forecasts? These are available in our API, but only in our V3. So for those of you who are already customers of ours, they're not in V2. They are updated as new production arrives, so pretty continuously there. And if you go look at our database, they're in these forecast well months, forecast well years, forecast well and forecast segments tables. That's where you can go find them. And just a little, this is a little confusing, but it'll be simpler in the next version of our API. But the legacy forecasts are called well forecasts, and the new ones are called forecast wells. So just make a quick note of that if you're going to use it. Last thing here is that the forecast well months, so that would be monthly volumes for every forecast. We only provide that for horizontals, and that's just because to do 50 years of forecasts for millions of vertical wells would just be too much data for our servers and for your downloads. But we do provide you yearly volumes, yearly average for the verticals, and then the segments you could use to generate monthly volumes for those if you want. Okay. If you are looking at the forecasts in our dashboards, those are available in a few different places. There's the supply projection dashboard, which you can use to forecast future volumes. There's the well economics dashboard, so that would include these forecasts, which is extremely useful as those young wells are often a huge part of the value for any economic evaluation. They are available in the production profiles forecast dashboards where you can just kind of look at them in rate time, cum time, or rate cum space. And then there is the any place where we have an EUR that is using our machine learning forecasts. So that's in a few different tables within our dashboards. Okay. And then I wanted to leave you guys, with a few customer testimonials here so you can kind of hear it directly from the customers who have been seeing these. One reservoir engineer at a large cap publicly traded operator said, "I was pleasantly surprised with the quality compared to other products and methods we've tried. The percentage of good or great forecasts are much, much higher." An RE at a large private operator said the projections seem noticeably better than both Big Data Company 1 and Big Data Company 2. We appreciate the variation at the beginning of the production streams for new wells, not just straight declines. And then a technical lead at a private equity firm said, "I was pretty impressed with the PDP forecast and the results are pretty consistent with what we have internally," which really for them means time savings. Okay. So thank you guys. Thanks everyone for hopping on today and going through my slides with me today. We're definitely happy to take questions now, and I see we already have a bunch in the chat, which I'll get to. Feel free to put more in there. But if you want to learn more about this or any other piece of Novi offerings, you can email us at intro@novilabs.com. And you can also email me for any feedback or questions. I'm happy to direct you to the right person. So my email address is there, tcross@novilabs.com. So go ahead and start putting questions in the chat there. I'll turn off the screen share and get to the questions that have already come in the chat. Okay. So George asks, is there a directionality of the area for the auto DCA versus the machine learning? Is it usually too big or too small? That's a great question. We actually, for the auto DCA, it tended not to be biased to over forecast or under forecast. It just was a little bit more erratic. Now that depends a little bit on the basin. I will say that like the Williston Basin has a very as far as production profiles go, it's kind of like the least hyperbolic. So up there, it did overestimate compared to some other basins. But normally the automatic DCA we find is not usually too big or too small. It's more a consequence of just it's a little bit more just erratic in its forecast. Now I will say, typically when we have run these exercises, looking at like operator forecasts versus ours, a lot of times we'll find that operators may have a tendency to forecast either too high or too low, and that's just based on the kind kind of cultural practices of the institution. So some companies might, you know, have different processes in place that push them more towards over forecasting or under forecasting their wells. So but there's hundreds of different things that we've seen there. But so James asks, if willing to share, are there any unique features that came to light in the model development? I won't share too much of our special sauce there, but we did have to put a lot of time into figuring out how to properly featureize the prior production. That was pretty important. And there was several other kind of key things there that we learned, but for IP purposes, I won't disclose anything more. Sean asked, do the outputs play nice with typical A&D cash flow evaluation software like Ares, CompuCurve, and PhD Win? Yes, definitely. We're happy to walk you through workflows into importing those in. It's pretty straightforward, and we've designed it to be easy to use in those. Okay. Now Benitez asks, wondering if you have come up with some type curve. Yeah, we also have evaluated type curve workflows here versus other forecasts. The type curves we find tend to be less accurate than Novi pre-drill forecasts, both of which are like less accurate than our machine learning once we have some production data has come in. And that the difference changes as you get more production data. So there's like a little bit of an improvement with 30 days, a big improvement with 60 days, a huge improvement with 90 days, and so on. Okay, Myra asks, how do you train in variations in operating facility, choke back early production, facility additions, etc.? So I'd say there's a couple things here. Number one is that the machine learning forecasts do look at how decline behavior changes from similar wells around the basin. And they do that by looking at similar wells, both in terms of things like the geology, but also the prior production history of the well. So, if you have a well which has been flat production for the first 9 months, the algorithm can find other wells that were in similar geology with a similar completions design, and see how those have trended later in their life. So that's one of the big advantages here in how they perform. And similarly, like they react well to maybe you have a well that's shut in for a while. So the algorithm will see that, and then as it comes back online, it will know that it's kind of had this production history where it had a stable decline for a while, and then it had a period where it's shut in, just as an example. Maria asks, are you planning to expand it into Canada? Yes, definitely. We have, for instance, I should say, yeah. So right now we're in the process of adding in Canadian production data into our database. Once we do that, we will expand the PDP forecast at the same time. So that's, in all likelihood, something for the second half of the year, maybe late second half, we'll have the forecast available for Canadian wells. Okay. George asks, do you get systematic bias gains in accuracy? For example, if I look at buying one well, I really value 30%. If I buy 100, the accuracy is not systematically biased. Yeah, it's a very good point, which is that, like, in the aggregate, how does that wedge change? We do get big gains in accuracy on the systematic bias. I don't have the numbers here in the screen. I mean, it's definitely not as big as the per well accuracy, but you might overvalue it by, let's say, 10% or 7% or something. Whereas the machine learning model gets like within just a couple percentage of what that total wedge does. It's a good question. Okay. All right. Rob Bergeron asks, how well does the ML recognize and handle extended flat initial segments transition to hyperbolic? Yeah, so that's what I mentioned earlier, where it can learn from that prior production history. So it can kind of, we don't know like when an operator is going to end their choke. Certainly that's something that maybe eventually we would want to bring in, but it does a good job by looking at other instances where something like that had happened. So that's just an example. Okay, thanks for joining, George. Yeah, thanks for the kind words there. Okay. Let's see. I think that's getting us through the questions here. I still have plenty more time if anybody has anything else. Um, just feel free to drop it in the chat. I'll give you another little bit of time here. Um, okay. Well, seems like that's it from everyone. Feel free to reach out at intro@novilabs.com. Um, put the chat there in the chat, and I'm also going to put T-Cross, my email at novilabs.com, also in the chat if you just want to copy those and reuse it. We will have a recording of this available for you guys to look back at later, or other people at your companies. So appreciate everyone hopping on today, and feel free to send me any other questions that you have as they come up. Thanks.